Welcome back to another episode of Rat Run with the Sudoku sisters. Okay, what are we doing today?
We're doing Rat Run number 4, Borderline, by Marty Sears. Regular Sudoku rules apply. So every row, column, and box will have to have the digits 1 through 9 with no repeats.
Usual Sudoku.
Thinks the rat must reach the cupcake by finding a path through the maze without visiting any cell more than once, crossing itself, or passing through any thick maze walls. Oh, it says diagonal moves are not possible in this maze.
Oh, that's
some of the
new.
some of the rat runs do allow diagonal moves.
Yeah.
If there is not a dot obstructing the path.
Okay. Noted.
Okay, we have black currants.
Black currants, which are called what in normal Sudoku?
Dots.
Crop key dots. Crop key.
Black crop key dots.
Crop key with a K.
Crop key dots. Which delineate digits that are in a 1-to-2 ratio, i.e. one is double the other. Not all possible black currants have been given, so we can still have digits in a 1-to-2 ratio, adjacent to one another with no dot.
Okay, got it.
We've got one-way doors.
Doors was that?
Sphinx may only pass directly through a purple arrow if moving in the direction the arrow is pointing. An arrow always points to the smaller of the two digits it sits between, like a greater than, less than symbol. So there will be passageways where Sphinx can only go from the larger digit to the smaller digit through the door. Okay. Here's the fun part, test constraint. In this experiment, the correct path will be a valid region sum line, which means that the box borders divide the path into segments, which each have the same sum. So all of the digits in each segment of the path will have to add up to the same
in
sum.
Each box.
Well, it's possible that a segment, there might be two segments in a box. Like if the path goes through a box, then exits the box and then re-enters the box, those two different segments will have to have the same sum.
Okay, so just like whenever the path goes through a box, the sum of those digits will have to be the same as the path in another box.
Yes.
Okay, let's go. Ooh, this is a pretty one. It's blue. That's new. Exciting.
And they've trapped that cupcake in a little dead end. So
that's true.
We already know the final 3 cells of the path. How exciting is that?
How do the path thing is this, right? Yeah.
Line tool, yellow.
Great.
Yeah.
Look at that. We already have a start. Okay.
And that
we could do our crop
that gives dots. Us we can do some crop dots. Yes, crop.
Let's do some crop key. So 1-to-2 ratios. So we've got 1, 2, 3, 4, 6, and 8.
Yep.
Should we do the rest of the crop key dots, or is that not helpful?
Wait until we have a little more information.
We could. But I'm on a roll.
Good lift them up.
There we go. Crop key dots.
Okay.
Oh, there's our purple arrows.
Okay. Yeah.
And they're facing the right way. Bigger to smaller.
Yeah, they're not like the last time. See why that made me so angry?
I do.
This is the correct.
This is correct. Do these purple arrows mean that the path has to go through these arrows?
It doesn't mean that the path has to go through the arrows, but it does mean that if the path does go through the arrows, the path can only go from the bigger to the smaller number. It can't go the other way.
Okay.
But no.
Got it.
Doesn't have to. One thing that we know just from the cupcake and its neighbor cell is that the sum of the segments on the path can never be more than 17, because the highest the highest sum that 2 digits can make in a Sudoku, 1 to 9 is 17, 8 plus 9.
But couldn't we have more line segments that go into that box?
Yes, but each line segment has to have its own sum.
Oh, you wouldn't add the 2 line segments together?
Nope. No.
Okay.
So, yeah. So the box borders, it says the box borders divide the path into segments, which each have the same sum. So even if the line went back into that box, it would be a new segment.
Okay.
Yeah.
So our segments max out at 17.
Yeah. Which can kind of limit some of the places that Finks can go. Like Finks can't go through those top 6 cells in box 1 because the lowest sum of 6 digits in a Sudoku is 21. 1 plus 2 plus 3
rattled that off.
Yeah, I know these things.
Wait, say that again for all our new viewers out there.
Okay, the smallest 6-digit sum, or 6 digits added together.
Like these 6.
The smallest 6 digits are 1 through 6.
Okay.
And those add up to 21.
Okay.
So if the path was to go through that little loopy area,
it would be too high because
it would be too high.
17 is the max.
Exactly.
So we can gray those out, is what you're telling me.
Yeah. Exactly.
Let's go. Grayed out.
Grayed out.
Awesome. Are there any other places like that?
Well, kind of looking at the top part of box 2.
Okay.
And wondering, like, is it possible for Finks to even enter through either one of those entrances? I suppose if Finks went through the entrance on row 1, I should probably pull out my annotation.
Oh yeah, I should do.
Yeah, if Finks went like that, we could have a segment that's minimum 15. So 15, 16, or 17.
5. 1, 2, 3, 4, 5 is the lowest it could be.
Yeah.
So that could work.
So that's a possible path. Yeah. But Finks wouldn't be able to just go straight to the cupcake from there.
Right, from there. Okay.
Oh.
He wouldn't. Well, okay. He wouldn't be able to go like this because that's 6 squares.
Yeah. We also can't go down through here. Did it show up yet?
It did, yeah.
Yeah.
1, 2, 3, 4, 5, 6. Right.
Yeah.
Okay.
So we could gray out that section.
Okay.
I'll try to remember how to erase.
Clear all drawings.
Which would also gray out that one cell above it.
Right there.
Right there.
Okay. Can we put a... Why is my X green? Aren't they normally red? I have to make it red.
It depends on what color you have selected.
Okay.
It could be green, pink, orange, red, dark blue, or gray.
I feel like they just automatically were red last time, but it's been a while.
You were probably just on the red tool. It's fine. Also, look at box.
Is that true? Can we do that? Put an X there?
We do what?
Can we put this X here? I guess I
don't think so.
Because I was thinking that if Finks went that way, the only way out is that way. And that's 6 squares.
Yeah, but Finks could go through there and then re-enter box 3, yeah. So that might happen. No, it can't. Finks can't cross its own path. But he could go down the other side.
Oh, yeah, because that's only 5 squares. If
Yeah.
you went like this.
Yeah.
Okay.
So Sphinx can take 5. Each segment can have a maximum of 5 squares.
Okay.
Okay. But I was also okay. So look at box 8.
Okay.
That little loop-de-doop section right there can't be on the path.
1, 2, 3, 4, 5, 6. Okay.
Yeah.
Whoops.
Although it's just 4 cells that can't be on the path actually.
Right, because it could be some of them, just not the
Yeah,
middle ones, right?
it can't be it can't be the 4 in the little U part.
Those 4?
No.
No.
It can't be these 4. Because if Finks went in through here, then Finks is forced to go here and then either there or there, which is too many
Gotcha.
cells.
But it could go on the other side.
Um,
Okay, so color
yeah.
gray.
So Finks could go this way.
Right. Okay. Okay. 1, 2, 3, 4, 5. I don't feel like I see any other spots with 6.
Yeah. I don't think I do either.
Okay.
Nothing that's forced.
Okay. Okay, so we've got our sum lines, our one-way doors. What else is there? We gotta get Finks to the cupcake. No diagonals. And the one-way thing.
Mm-hmm.
Okay. What about in box 9?
Oh.
These 4 squares, he's gonna have to go through. Oh, no. He doesn't have to go through box 9 at all, right?
Not necessarily.
Yeah. Okay. Never mind.
That's okay.
What about over here? There's an awful lot of crop key dot action.
That's
Do we
true.
know enough about it yet?
I don't know if we do. Let me think. So plus 4 is 12. So yeah, if the path went through the crop key dots, could still be the high ones. I'm feeling like we might just have to take a look at the different ways the path could go.
Okay. You like going backwards from the cupcake? Or starting from Finks?
I'm not sure.
Okay.
I just know like the purple, the one-way doors are gonna help us figure out where the path can and can't go, but there's still kind of too many possibilities. It's like I was thinking that Finks could not go down this way because of this one way
pass through this arrow.
Yeah, but Finks could go this way and then like back up. So that's just kind of annoying.
Right.
What
about this one? I guess technically he could still do that. Wait a minute.
I wonder what the what the minimum possible sum would be. Like we know that the maximum possible sum is 17.
Wouldn't the
But
minimum be 3?
mm,
Oh, well,
would it be
no,
possible
because
to only take 2 digits for each section?
that would be a really crazy path. Maybe that's how
Well,
we could figure that
and
out.
it wouldn't be possible either. Like this digit right here, if our minimum was 3, it would have to be a 1 or a 2, and that would
Yeah,
see both of these digits.
right.
So,
Okay.
whoops. Trying to clear that. Where's trying to clear that? Where's the clearing tool? Okay.
So far, it's got to be bigger than 3.
Mhm.
What about 4? 1 and 3?
Mm-mm.
It couldn't be that.
It can't be. It can't be a sum that only has two possible digits, which
Okay.
actually means
Wait,
it
why?
can't be 17.
Oh.
Well, because like even just right here in the 3 cells that we have in a line,
Mm-hmm.
um, there's only one way to make 17, and that's with a 9 and an 8.
Mm-hmm.
So what's the next cell going to be if it has to add up to oh wait.
It could
Wait,
be anything because of the box border, right?
What?
Couldn't it still be anything because of the box border?
Yeah, that doesn't work with the maximum, but it does work with the minimum. So if the minimum
Okay.
was 4,
Yeah.
then it could only be made up of 1s, 3s, and 4 if there was only one cell being traveled. But
Uh-huh.
like this can't be a 1 or a 3 because it sees the 1 and the 3 below it.
Right. But it could still be
So our
like a
minimum.
2 and a 4.
What? Huh?
Like if this were a 1 and a 3, totaling 4,
Yeah.
couldn't these boxes still be a 2 and a 4, but then maybe the path would go this way, but I guess then this would have to be a 2, and you can't do that because of Sudoku.
Right. So no.
So no. Okay. So not a 4. 5?
Only if it's possible to get to the cupcake by only taking 2 cells per box or like 2 cells per segment.
Right, because you can't make 5 with 3. So
Right.
maybe we should figure that out. Is there a path that he could take that only ever involves 2 cells per box?
Yeah. Or like what are the minimum number of cells required? Like what is the smallest path that we could possibly
Okay.
take?
Okay. So here, if he goes right here, that's 2 in that box.
Mm-hmm.
And then
And then
2. There's no way
but he
that
can't the one-way door.
Oh, right, the one-way door, because we're going backwards.
We're going backwards, yeah.
Okay, so we can't go that way.
So it would have to go back into box 5 and take 3 cells.
Yeah. So it's got to at least be 3 cells.
Yeah. And um so normally ew. Sorry, dead bug. Normally the smallest digit that is the sum of 3 cells would be 6.
6.
But then that's 1 plus 2 plus 3.
Uh-huh.
Then you would also need 2 different digits to add up to 6 for the first or for those last 2 cells to the cupcake.
These guys.
So it can't be 6.
Right, because
Yeah. Because 6 is 2 plus 4 or 1 plus 5. And we would already need the 1 and the 2 in the 1, 2, 3.
in right here.
Yeah. So I'm saying six can't be the
But
minimum.
it doesn't have to go that way. Couldn't it go this way?
Yeah, but that would be 4 digits.
1, 2, 3,
So
4. Okay.
yeah,
Okay. So
trying to figure out like what the
what the
smallest
minimum
possible.
is. Okay. So it's got to be bigger than 6. Could it be
Yeah,
7?
7 is 1 plus 2 plus 4. That's the only way to make 7 with
With
three
3.
digits. And
1,
then
2, 4. And then 3, 4, 5, 2, 6, 1 uses all of those digits.
yeah, so it can't be 7.
Okay.
I think it can be 8. 'Cause 8 is either 1, 2, 5 or 1, 3, 4. Um,
And then you could do 7 and 1, 6 and 2, 5
it could
and
be 2 plus
3,
6 and then 1, 3, 4. Yeah.
2 and 6 and 1, 3, 4. Could do it.
Yeah.
But that's
But
only one.
you know what else I just noticed?
What?
If our path did go this way, um, would I think it would have to go that way? Well, maybe it could go this way.
Oh, this way?
Yeah.
Mm-hmm.
Um, what I was gonna say is that it would have to go back through here, I thought. Like if Finks wound up over here somehow to get to the cupcake from here, Finks would either have to go that way or this way. It's getting really busy. What I'm trying to say is I think that there's no way that we would only have segments that are 3 digits or less.
Okay.
I think we would have to have 4 digits somewhere.
Okay.
And I don't know how to prove that.
Something about here or here or here. Got it? Great.
It's also clear now. Yes.
So you're sort of suggesting that maybe 7 is not the minimum, that we might need a bigger minimum.
Yeah.
Because we might not be able to constrict it to
Yes.
the 3
I'm
squares.
thinking,
but we're a little shy on the proof. It's more of a gut feel.
Yeah. I would love to prove it, but I'm not sure how.
Okay. That's fair. I bet it'll come to you.
Yeah. Like,
I feel like we're gonna get our first digit really soon. We're so close to the first digit of this puzzle.
Totally. Okay, so the max is actually not 17, though.
What? Why not?
The max is not even 16. Because, oh wait, maybe it is. Never mind.
Are you saying it's less than that? Because it can't be a 9 and an 8 for some reason?
No, I was wrong. I was thinking, so I've been thinking that the path was the path was going to take 2 cells above the first 2 cells, and there's no reason to think that.
No, because it could go this way.
It stuck in my head.
Okay.
That it was going to be a 2-cell segment. So never mind, it could be 17 max.
Okay. And right now we have the minimum as 7, but we're unsure about that. Question mark.
Yeah.
Okay.
But can Finks get to the cupcake without re-entering cell box 5?
That's a good question. Not going this way, because that's going the wrong way through that purple arrow.
Mm-hmm.
So then it would have to be this way. Wait. That's re-entering box 5. So then...
Yeah.
1, 2, 3, 4, 5, 6. That's 6.
It's a no.
So no, he has to re-enter box 5.
Okay. Then the only way that the sum could be 17 would be if Finks takes these 3 cells and then doesn't re-enter box 5.
Again.
Because you can make 17 with 3 digits and not need to use the 9 and the 8. But if you were to go through any of those 2 cell segments, you'd need the 9 and the 8.
Okay. So I don't think that's possible because he can't go here through, because we're still running him backwards from the cupcake.
Yeah.
So
you would have to
go this way, which gives us another 2 square segments.
Yeah, but the only way to get here would be to go through here. Right? That's the only other entrance to this spot.
Yeah. So we're going to have to have, like, this whole box is going to have his path through it.
Maybe.
I
think it's possible that we might not need these 3 cells right here.
Which 3?
The 3 I just made red. Because, like, he could go down here over, do some kind of whatever here, but then he's going to end up back here. And he could go through that door. And then, no, I think he is going to have to. Because he can't, there's no way he can, like, not retrace his path. See what I mean?
Kind of.
This is making any sense at all.
It's a little tricky because your path doesn't show up until you're done drawing the whole thing.
Oh, that's annoying. I'm like demonstrating here,
and here. Got it.
I'll work on that. Maybe I can do it in a different way.
Zoom should figure out how to do that better.
I know, right? There should be live annotations.
Yes. Live annotations, please. Zoom.
Oh, I was trying to erase your squiggles.
Here, I'll erase them. Boop, boop. Maybe.
Oh, that's okay.
I feel like maybe we're close to feeling like we're going to have the path go through every single square in box 5.
Maybe. I'm trying to think if there's a way for Finks to not have to go this way. Like, if he goes down this way and then through there. He could get there.
Yeah.
Probably won't. Like, usually in these rat runs, the path is very convoluted and goes everywhere, but
not so direct.
Yeah.
But we can't assume that.
No. I'm annoyed that we still can't quite figure out. I mean, we haven't ruled out him going a different direction. But we do know that he's got to go through I think maybe every cell in box 5. Can we prove that or no?
That's a great question. I feel like we were onto something with these. Like,
wait, he can't. Hold on.
Okay.
So the sum of every box is 45, 1 through 9.
Yes.
And if Finks were to go through every cell in box 5,
Mm-hmm.
each segment, there would be 4 separate segments, and they would all have to have the same sum.
Mm-hmm.
So 45 divided by 4 is not an
Oh,
even whole number.
right.
So Finks can't go through
Can't
every
go through all the boxes.
cell.
Okay, that's good to know. Let's write that down.
Let's write
Can't
that down.
go through all of box 5. Okay.
So
Okay, so what if he goes this way? He could go that way or that way.
yeah.
And then
But whatever he does in that section, he would
yeah.
end up having to go through the yeah where you had your cursor. I'm trying to find it, like right here.
Yes. Yeah.
And then here. And not
And not
here.
there. And not there.
Yeah, so it'd have to be here. Yep. Okay.
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 But he could go the other way, like this way.
Mm-hmm.
Um, but if he went that way, then he wouldn't be able to go this way because then the only way back to the start
Oh, is
would be to
through.
go back through box 5, which we've just proven he can't.
Okay. Okay, so if he went
So,
that way, he would have to also join up with the path
yes,
right there.
here. So this has to be part of the path.
Yeah.
We figured something out.
What?
Let's mark that.
Should we color those cells?
Yeah, something.
I'm still trying to figure out if there's any way. No. For Finks. Okay, I'm pretty sure this is not possible, but I think I need to draw it one more time just to see it.
Okay.
Like, wait, what was I looking at? Oh, like Finks going through here, doing some kind of stuff, whatever, and then going back through here, and then like taking a different way to the cupcake. Like he could go this way.
Don't forget to pick up your pencil.
I did.
Okay, so you're saying like he goes kind of this way, down, something, something.
Yeah, well,
around.
he would have to go this.
He can go through this way because we're taking him the right direction this time. And then back through. Because then you're only missing one box out of box 5. So you could potentially have like a total of 44, which is divisible by 4. And 11.
Yeah. Or 40.
You can have 4 different pairs that add up to 11, right? 9 and 2, 8 and 3, 7 and 4, 6 and 5. Is that the only... That's the only number that has 4 pairs for it, right?
No, 10 also has 4 pairs.
Really? 1, 9, 2, 8. Yeah.
Yeah, so that digit could be 1 or...
But to get 10 4 times, your total would be 40. Oh, no, that would work because then you'd pull out the 5.
Oh, but what wouldn't work is that path would require a minimum of 15 in this section.
A minimum of 15 in that section. Walk me through that. I didn't quite catch that.
Okay, because Finks would have to take 5 cells in one segment here. And
Okay.
the minimum sum of five
1, 2, 3,
digits
4,
is
5.
15. 1 plus 2 plus 3 plus 4 plus 5. So the smallest sum that could result in would be 15.
Not
And
11.
then there's not 11. And then there's only two ways to make 15
Right.
with two digits. So
Okay.
that path isn't
The
possible.
path isn't possible. Okay. How do we notate that? I don't
I don't know.
know.
That was opposed to like, what was the other proposal we had going on?
um, I think it was working backwards from the cupcake. Whoops, I just cleared everything. Oh
That
well.
is probably good.
Probably.
A lot of things to look at.
Clear as mud. Maybe it was going like this. Because we had determined that this section was part of the path, no matter whether
Mm-hmm.
going back from the cupcake you went this way or this way. Either way, you had to go through here,
Yeah.
which meant you then had to go around to here. So it's
Okay.
almost like, I think, can't we determine that all of this is on the path?
I think so.
Okay, let's do it.
Okay.
Okay.
Feels like a big commitment.
It feels like headway. Whoa, whoa,
Whoa,
whoa.
whoa, whoa.
Let's try that
Well,
again.
can we just color code the whole cell instead of because like
Instead of the path.
if we know for sure it has to be on the path, we could shade in the cell pink or something.
Okay. What do you have against the green line?
Oh, just that we're also using green lines to try to figure out possible paths and
Mm-hmm.
um I guess like I I feel like there's two different types of logic happening at the same time. Like the cell being on the path is a different kind of logic from here's where the path is and where it's going. If that makes any sense. Like so for my brain it helps me to have color coded like these cells are part of the path
Okay.
separate from this is where the path is going.
You might need to explain that a little further because that makes no sense to me. But I do feel like you might have a point, but I don't
it's
understand
it's
it.
it's just it helps visualize like what we know for certain is part of the path. It's kind of like we gray out the cells that aren't on the path instead of just being like, well, there's no line on them, so they're not on the path. You know what
I
I mean?
still don't quite understand. Like, we color them pink or we put a green line through them. It's still sort of
Both.
doing the same thing.
Both, because one is path centric and one is cell centric.
Okay. So do you want both or is that a little bit busy?
Yes, I think both is not overkill at all, and I believe our three viewers will also appreciate it.
Comment below
Let
whether you
us know what
agree.
color you would like us to shade the cells that are on the path.
Do you agree we need both the green line and the pink shaded cells? Or just one or the other? What's your preference?
Yeah.
Yeah, okay. Um, well, doesn't that mean that this one also has to be both pink and green?
Yes.
You're just trying to
Oh,
make.
wait. Don't attach it to Finks. We don't know.
No, I wasn't going to go all the way up to Finks. Just
Oh,
here.
okay.
Just here. Just there.
Although,
Oh, no. No. Because those are arrows. He can't go through the arrows, right?
yeah, and
I mean,
he
the wrong
can't.
direction.
Yeah, no, it's just like I wanted to make sure it wasn't like this, but that's 6 cells, so that doesn't work.
Oh. So does that mean he has to
Um,
go right to Finks right there?
Well, maybe, but I'm also like still not thoroughly convinced
That it has to go this
that
way?
Finks didn't go. Wait, we did prove that it can't be this, right?
One, two, three. I think so, but
Yeah,
I
yeah.
don't remember
That makes it
why.
have to be 15.
Oh, yeah,
Oh
yeah,
my
yeah, yeah.
God. Okay.
Wait, what about the 15? Why was that wrong? The
um,
smallest it could be is 15. Oh, and that
yeah,
only has two ways to get 15.
yeah. So
And
then
we
box five.
know that it has to go more than twice through box five.
Yeah,
Do
with
we
two
know
digit.
that, though? What if it just goes like this? Like, boop, 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 boop.
No, like it could. Um, what I was having to somehow prove to myself like four different times was that Finks can't go this way
Mm,
and
right.
then
Because
and
then
then
that creates
wind
the
up here.
four sections through box five.
Yeah.
And those four
Yeah.
sections, that's not enough different digits to add up to 15.
Right. So
But
he could still just
couldn't these five cells add up to 17? They don't
sure.
have to add up to
But
15.
that still
Oh,
wouldn't
that's
work
still too many
because
because only 9 and 8 add up to 17.
yeah, so we need the maximum to never mind. That
Yeah,
doesn't mean we need the maximum to be less than 16. It just means it can't go through those five cells.
we need to gray those out, is what you're telling me. Right?
Oh god.
He can't go that way.
Well,
What? We just proved it.
no, 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 we didn't prove anything.
Ugh.
Or maybe we did.
I
I don't
thought we
know.
did.
Ugh.
Wait. Okay, let's prove this. We can do this.
Okay.
If the path goes this way, it's going to have to go through those five boxes. The smallest number sum we could get for those five boxes is 15. So then, to have any chance of making it back to the cupcake, it has to go through at least that. No, still has to get to the cupcake.
Mm-hmm.
Let me think here. So it would have to go there.
And it can't because that would take up all of the cells in box five.
Right.
Oh my god.
Okay, so we've proved it can't go that way. So then the
Uh-huh.
only other option is for it to go through here. And we can do through this arrow now because we're going the right direction that Finks is going.
Yeah.
And he still has to get back to the cupcake. So the only way to do that is to go back this way.
Yeah.
Which doesn't go through that box, but it's still going through the box four different times.
Yeah.
And there's no way for those four different
11.
sections to add up to 15 using different digits. So we have proven that this is true. It cannot go through those.
Okay.
Yeah?
Yes.
Woo! Okay, good job.
But wait.
No!
What
Okay.
if?
Okay, what?
No, but hold on. Just hold on a second.
Okay. Holding on.
I don't think that we have necessarily proven that Finks isn't getting to the cupcake by taking a path like this. I think that's what I'm saying. Like,
Oh.
he could go down this way, blah 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 blah, and then wind up doing some whatever, and then going there to get the cupcake.
Okay.
So that's why I didn't want to gray out all those cells.
Got you. But we could gray out the three on the top.
Yeah.
Okay. I'm good with that.
Okay.
Okay. Whoa. What did I just do?
Whoa.
Oh my. Okay. Okay. But if
Holy
the
moly.
three on the top are grayed out, then this one can't either. How many rat runs are there?
Like 37. Like that. Hours of your life.
At what
Um,
timestamp do Simon and Mark find their first digit on rat run number
I think
4?
I think we should check after we finish this.
Maybe less than 42? But it's okay, right? You're not here for quick Sudoku.
No, our audience is here for um their own reasons.
For
That's
I don't know why.
not ours. Audience, what are you here for?
Comment
Go ahead and comment
below.
below the video.
Are you? If you're still here, please note
Why?
in the comments. 42
We
minutes in,
beg
and
of
I'm
you.
still
Tell us
here,
why.
still listening.
Why have you been watching this for 40 minutes?
Because there's really nothing better to do with your time.
Maybe we should do this with our feet in the frame.
That'll really spice things up.
Yes. This is your Sudoku Daddy. Thank you for tuning in for 50 minutes. Should we do this on live? Thank you for the rose. Okay.
Yeah, was that Cam something or other?
Cam girls.
Cam girls.
That's us.
Pretty close. Pretty close.
Mm-hmm. Mm-hmm. The right price, you can watch us navigate this rat to the cupcake. All right.
All those novels you've been reading might just come in handy.
Let's hope not.
Okay.
Okay. Maybe the Cryptic can tell us which direction.
Oh.
What?
Well, I was going to say, with these grayed out squares up here, cells, we could gray out more cells, because he's not going to be able to go through those two.
Okay.
Yeah. Okay.
Sure. Also, well, I feel like he can't go up and around because that would take 6.
6 cells, or if he goes down, then he gets stuck by that purple arrow. If he goes up here.
So are we proving that Finks is going straight down?
I think we just proved he's going straight down.
Wow.
That's
really exciting.
Let's mark that in both green and pink.
Okay, then.
Green. Do I need to mark his square pink? I guess so. Whoops. What just happened?
You're using the line tool.
Can't quite
Not the shading tool. Okay, so
we're really getting somewhere.
Oh my gosh, we're getting so far. Yeah. So now we have a minimum of 10.
A minimum of 10? Oh.
Yes. Because of those 4 cells in box 9.
Yes. Minimum of 10.
Uh-huh.
Min 10.
Min 10.
Still max 17. We're zeroing in on it.
Although, I don't think so. I don't think our max can be 17 anymore. Okay. And here's why. Okay. Let me tell you why.
Because it's going to go through box 5 again, right? And there's no other way to get 17.
Yeah. The only way to get 17 would be to take 3 digits instead of 2.
Right. Okay.
But also, I was going to point out too that if we went up from there, then this digit would have to be 8 to make it 17. 8 and 9. And then this would be 8 and 9 too. So that's not possible.
Okay. And I don't think we're not going to be able to get a segment of 3 in box 5 with our current situation.
Right.
Because 3 is only going to happen here, but we know this is here. So it's either going to go up for 2 or down for 2.
Yeah. Yeah, yeah.
Okay.
So
So max is not
it would
17 anymore.
it would be really helpful if we knew for sure that the path went through here and here. Because then we could determine that this digit is either a 1 or a 5, making all of these segments either 10 or 11.
Because those are the only ways to do 4 of the same sum.
Um, 4 of the same sum, which would be at least 10, because this box down here
makes it
so that our minimum is 10. So we could either have 4 segments of 10 and then 5 left over, or 4 segments of 11 with 1 left over.
Got it.
But we don't know that that's where the path goes yet.
Because if it didn't go that way, it would have to go this way.
Yeah.
So if we can,
seems crazy to me.
What's crazy?
I don't think Marty Sears would do that.
That's not good
not
logic.
Not a let's go the most efficient way kind of a puzzle setter.
True. But I bet there's a way to prove that this is not the way that it goes.
Probably. We'll get there eventually, maybe.
We could try it right now.
Okay.
Okay. Okay. So we have minimum 10.
Oh. I know how.
Yeah?
Yeah.
Okay. Enlighten us.
Okay. It's the box border thing. So these would be their own segment.
Oh.
And they have to be at least 10,
yes.
which we can't do.
Yes. Oh, yay.
We have our first pencil marked digit.
Wait, we have a digit?
Well, no, we don't. But we do know that this right here is a 1 or a 5.
Oh my gosh. Okay, hold on. You're like a little bit of a step ahead of me. I would like to gray out these, but I'm having trouble.
Yeah, you
are. Okay, gray. Okay, now you're saying that. Oh, yeah. Because if it doesn't go this way, it has to go through the other boxes, the other cells, I mean.
Oh, yeah. All but one.
The sum is either going to be 10 or 11.
Yes.
Because it's leaving out this one box. Sorry, this one cell. And the only options for that are 1 and 5. And we have our first pencil marking, which is what you just said. But now that I've said it, I get
it. You got to verbal process it.
Yeah, verbal process. Okay, pencil marking commencing 1, 5. Yes! 50 minutes in for the first pencil mark.
We have our first almost nearly a digit.
We had all the crop key dots pencil marked. That sort of counts.
Well, we can do something else. Like now that we know that our total is either 11 or 10. Mm-hmm. Like those four digits in box 9, they're gonna have to either be 1, 2, 3, 4 or 1, 2, 3, 5.
Ooh, more pencil marking.
But I think we can even do better than that, because if 1, 2, and 3 are definitely on that segment, that limits our crop key dot situation to 4 and 8.
Oh, nice. Right.
Which means I think our sum is going to be 11 for each segment. Because for it to be 10, we would need the 4.
Right, because the 4 is already taken.
Yeah.
Look at you, logicking.
Logic hang. Okay.
So we know our sum. Our sum is 11.
Yeah, which means we do have a digit.
Our first digit?
Yeah.
Wait. Let me see
Tell
if I
Paul
can
to make
figure
a
it out.
couple more old fashions.
Oh, it's the one with the 5.
Yep.
Hold on. Oh, I'm in the wrong thing. Okay. And so, okay, since our sums are 11, the 4 sections have to, that's 44. All of the cells have to add up to 45. So this, my friends, is going to be a 1.
Woo! Go! Go
We got our first digit! If you're still with us, we hope you're as excited as we are.
Comment below. Why? What are you doing?
Because it's
what are you doing with your life?
fun.
Seriously, is this really the best you can do?
Yes.
Just watch this video on YouTube.
I mean, think of how many things this is better than.
I know, and literally I watch so many Sudoku videos. I'm being judgy for funsies.
Totally.
Because
I mean, think of all those suckers watching the USA play Turkey right now.
I know, like, who even cares?
You can just watch the highlights later.
Yeah.
Okay.
Soccer, football,
suckers.
Okay. Suckers.
Okay, so the path needs to go down this way. Let's finish our path. Boop, 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 boop.
Yep.
All pink, and green.
It doesn't have to be pink and green. I'm giving a hypothetical.
Wait, why does it not have to be pink and green?
I just wanted it to be shaded and pathed.
It is
separately.
both shaded and pathed. You're saying it's not about the colors necessarily, just we need shades and paths. Have we talked yet about our neurodivergence?
I don't think we have to. And when you say we, do you mean me or you? Are you neurodivergent?
In my own special way.
Right, I forgot you're autistic.
I am not.
Okay.
You're being rude to all the actually autistic people out there.
No, I'm not. Autistic people are beautiful. Your brains are beautiful.
Stop talking
all
to
5
me.
of our subscribers.
Do we have 5 now? Oh, we only had 4.
I don't know. We should.
I haven't checked in a little while.
I've never checked. What's our channel again? I don't even know how to. Where's it going?
Well, it's a little confusing because the title is Puzzle Nerds Get Digits. Very clever, by the way. But our little @ symbol thing, whatever that means, is Sudoku Sisters. What?
Okay.
What?
Nothing.
Cute.
I want to solve this.
Okay. Let's do it. I think we can do more shading and pathing.
Oh, yes, we can.
Yes, we can.
Because, okay, so that also has to be 1, 2, 3, 5. That segment right there.
Hold
okay,
on.
this isn't shading or pathing.
Talking. I'm trying to path. No, this is not pathing. This is shading, but it's not working out.
Stop trying to make fetch happen.
What is happening?
Who said pathing is a verb?
It is now.
Okay, well, I was trying to, I don't know, solve the puzzle with logic. Sorry. Sorry to interrupt your shading and pathing.
You were the one that needed both path and shade. Okay. Go ahead with your solving.
Okay. The 4-digit segment in box 2 has to be 1, 2, 3, 5.
I mean, that's what I meant.
Right.
1, 2, 3, 5. Because we're adding to 11.
And the only 2 digits that could fit on the crop key dots, I mean, the black currants, would be 1 and 2.
Oh, so nice. Okay. So we're taking out the
other 2 are 3 and 5.
1, 2. So then the other ones are 3 and 5.
Yes.
Which is what you just said. I'm just clarifying. For all our subscribers,
my sister.
listeners out there.
Another excellent deduction.
An excellent what?
Deduction. You deduced it correctly. I'm sorry. It's been a long time. We've been on this call for 2 hours, I think.
Oh, have we? We weren't talking for an hour before we started, were we? Oh, maybe we were.
We made it.
We started like at 6:30.
Yeah.
Do we need to cut this in half and do part two?
No, we need to solve this thing.
Okay.
I'm not complaining.
Let's go.
I love a long Sudoku video.
Me too.
I know, right?
Comment below if you do too.
You know what? I bet we could place the 3 digits at the bottom of box 9.
Ooh, yeah, because of the arrows, the purple arrows.
Yeah.
Do those not have a special name? They're just purple arrows? That seems wrong.
Inequality signs? I don't know.
I need one like blackcurrant or crop.
976.
Fog lines. 976. Boom. 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 3 more digits. Woo! Okay, that was exciting.
Now. It is, right?
It is. I agree.
Excuse me.
Oh, wow.
Terribly.
Okay.
I wonder.
We could maybe talk about these 2 digits, but there's a lot of options still.
The one column over to the left might be more restricted.
Okay.
Because it can't be 3, 8, or 5, 6. So it has to be 4, 7 or 2, 9. That's not super restricted, but
a little bit. Oh, right. For a second there, I forgot we were adding to 11. I was
yeah.
Okay. Adding to 11. Okay. Can we do? Oh, what about these 4 here? Oh, but it's not within a box.
Different boxes.
Yeah. Okay. What about these 3? 3 that add to 11, and it can't be a 7.
There's a lot of options, but I don't remember what they are.
Yeah. That does sound like a lot.
There's a lot of ways to add up to 7 that way.
But we know. Yeah, let's find somewhere else that's better.
Oh, so we can never take more than 4 cells in one segment now. Because 5 cells can only add up to 15 or more.
Yeah. Okay.
So
that can help with the path.
Yeah, I was just thinking we probably can't go down this way. Oh wait, yeah, we could. We could go 1, 2, those 3, 4. But
we could cross some of these off. It can't be these 3.
Right. Okay. Yeah.
Okay, so need our colors. And these 3 are gray. Okay. That means it can't be these 3 also, right?
Well, not necessarily.
Why not?
Well,
because it's not in one box.
Right.
Forgot about the box lines.
Yeah. Right. Because we could have a path that goes through this way. And then it would be 3 that add up to 11. 4. Yeah, there's still like a lot of options. It could go this way, or it could go that way.
Go down and over.
Or this way.
What about, can we do something with, like, if it went through here, then it, like, maybe it couldn't, something about the crop key dots not adding up to 11. Like, it can't be 4 and 8, because that would be
Right.
12. 3 and 6 would be 9, but then the other one could be 2. Maybe there's nothing there.
Yeah, because we'll also like it, the path could go through just one of those. It doesn't necessarily have to go through the dot.
Right. That's true.
The black currant. Um, yeah. Trying to think if it's possible for the path to go through column 2 in box 4. Like,
Column
can it
2
go
in
this
box
way?
4.
I think no.
Because it would have to be 1, 2, 3, 4, 5 cells, which we
Yeah.
determined is too many.
Yeah.
What if it could it loop around like
This?
this? No, it can't, because then it would go through this square twice.
Yeah.
But okay, what about the one you just did was up here and then like that?
Mhm. Yeah, I think that's possible.
Mm-hmm.
It might even be possible for it to go this way.
Mm-hmm.
Because then you would have these would be 1, 2, 3, and 5.
1, 2, 3, 5.
Yeah. Okay. Why is this so hard? I feel like there's probably some really obvious stuff that we're missing.
Probably.
But I don't know what it is.
This box has to be at least 2. 2 through 8. And not 7.
Sorry, I saw something different. What did you just say?
This box here has to be at least 2 and max of 8. So, only 2, 3, 4, 5, 6, or 8.
Okay, I have something better than that.
Okay.
The path cannot go this way because then this digit would have to be 11.
Yeah, that is
good. So we'll go this way.
Okay. And that doesn't necessarily mean that it can't go through. Oh, no, it can't go through this box. This has to be gray.
You are so into graying out cells.
Well, you're into pinking them. But is that right? Because it can't go back through. If it goes the red line that you drew, it can't go back through.
Yeah, I
Because
think
that would
so.
be 5 cells. And
Right.
that's a max of 15.
And it also can't go through this one either, because that would also be 5 cells.
1, 2, 3, 4, 5. Great.
Yeah.
Gray it out.
So I think it's gonna have to do this green path.
Shade and path. Shade and path. Boom, boom, boom.
Which means we can place the 5. Maybe I'm getting ahead of.
Okay, hold on. I gotta do the path thing.
Shade it and path it and shade it and path it and shade it and path it and gray the rest out. Shade it and path it.
This one has to be gray then too.
The rest out.
Okay. So then you're talking about placing a digit, which is very exciting. Talking about placing a 5 for some reason.
Because, okay, so the path can't go this way from where it is. That would take 5 cells.
Okay.
Yeah.
Got it.
So because we've taken 4 cells here, we are restricted to using digits 1, 2, 3, and 5 in those 4 cells.
In box 7. I can't see where you are.
Yes, in box 7.
Okay.
And then
these
also
are what you're talking about.
Yeah, but then also the path can only go this way in box 4, which also takes up 4 cells.
1, 2, 3, 4. Okay.
So those cells have to be 1, 2, 3, and 5, which means that these 4 cells here are also going to be from the set 1, 2, 3, 4, or 1, 2, 3, and 5.
Because okay, hold on. Because those 4 cells are connecting the 2 paths that have to be 1, 2, 3, 4, 5. Sorry, 1, 2, 3, 5. So
yeah,
these 4 have to add up to 11. 1, 2, 3, 5.
Yeah.
And these 4 have to add up to 11. 1, 2, 3, 5.
Exactly.
So these 4. Wait, let me try that again.
Pick a different color.
So these 4 also have to be 1, 2, 3, or 5. And there's Cryptic dots.
Yeah, and the only digit that can't be on a Cryptic dot is 5.
So the 5 has to go here.
Right.
Wow. Awesome. Numbers and 5. Oh
no! What just happened? That was so get ready for blast off coded.
Hold on. I cannot do. See?
Everything is 5. Done.
Got a little excited about that 5. Okay, clear the drawings. And then these cannot be 6s or 8s or 4s.
Right.
Which means this cannot be an 8 or a 3 or a...
Where are you? What are you doing?
What? I thought you were with me.
I was until you started talking about this cannot be an 8 or a 4.
This square right here, because of the because of the black current.
Yeah.
Because this can only be 1, 2, or 3.
And right? There's only one place the 3 can go.
Oh gosh, you're always just a step ahead of me.
Oh my God. Sorry that my 10,000 hours were in solving variant Sudoku. Everybody's got to have something they can do.
We all have to have something. Okay, so you're saying we can place the 3. It can't be here or here.
Can you right, because it can only be paired with a 6.
With a 6, so that has to be
in the Cryptic universe.
The numbers are falling, people. Falling. So then no 3.
Falling into place. Whoa.
No 3s and no 5s. And then this cannot be a 3, so this cannot be a 6.
And it can't be a 1 or a 2 either.
1 or 2, because Sudoku. So this cannot be a 1. Or is that it? 8.
That's it.
That's it.
That's it. Okay.
We're doing well.
Well, it can't be 8 either. Because the path is going to go through that 3-digit segment. And if it was 4, 8, that would be 12, which is too big.
Too big. Okay. So no 8s on that. No
it's
8.
Either
no 8.
2, 4 or 3, 6.
Right. So no 4. Oh, whoa.
Whoa.
Okay.
Ooh, then, it can't be 3, 6.
Because there's wait. because 6 is, wait, no. 3, 6, 3. Just let me catch up.
Wait. Oh, wait. Go on.
It can't
Tell me
be
where it can't be
3,
6.
6. I don't know. I gotta think through this. It can't be 3, 6 because that adds up to 9. So we would need a 2 on that other segment, but can it be a 2? Oh, no. Okay, I'm catching up. So this, if it was 3 and 6, this box right here in box 1 would have to be a 2, but then the purple arrow means that the 2 has to be bigger than this one, which would make this a 1, and that cannot be a 1 because of Sudoku.
Bingo.
Yes. Took me a moment, but we got there. Okay. 2. Oh no. 2.
Oh no.
4. Great. So then we can place this digit.
Yeah.
Because 2 plus 4 is 6. 6 plus 5 is 11. 5. So, this has got to be a 2, 3, or 4 because those are less than 5.
Yeah, but it can't be a 2 because there's already a 2 in that box.
Going to be a 2, and that's a thing. That's a hidden single, hidden pair, locked pair, locked candidates. It's okay. It doesn't matter. Can't be a 2 is the point. Okay, and those 2
hidden single nigga pair candidates.
Chocolate teapot.
Starfish. X-wing.
Yeah. X-wing, Y-wing, XYZ wing. We haven't gotten there yet.
Blue wing, 1 wing, 2 wing.
Okay, 3 plus 8 is 11, and 4 plus 7 is 11. So this would have to be 8 or 7, right?
What?
Well, it's a little confusing because we haven't pathed and shaded all of them.
Yeah, we haven't grayed out.
Let's see.
Also, we have some more digits in row 3 that I really wish you would place.
I'm getting there. I got a shade and path. Oh no.
And a shade, I got a path. Gotta play around with the line tool. Put an X here, put a 0 there. I don't know what is happening.
See, part of the problem with both shading and pathing is that it takes a minute. Maybe one of these days you should host the Zoom meeting and then you could do all this stuff. But then I feel like you would just solve the puzzle and I would be
No. It would be good practice to try to slow down.
This is my one way of controlling the flow of the solve. Wait for me.
We know which digit. Hold on. Mm-hmm. Okay.
What else do we know?
Oh, you know what we can do real quick?
What?
Is Sphinx is a 3.
Sphinx is a 3. Okay.
Yeah. Because in row 3, the cell below Sphinx can only be 6, 7, 8, or 9, but it sees a 7, so it can't be 7. If it was 6, then Sphinx would be 5, which conflicts with the other 5 in that row. So Sphinx is either 8 or 9. Or no, that cell is either 8 or 9. But if it was 9, then Sphinx would be 2, and that also conflicts with the 2.
I see. Gotcha. Excellent work.
Check.
Okay. I think we're really getting somewhere here.
Ooh. And that makes the 3, that places the 3 in box 9.
Places the 3 in box 9 because that's the only one that can be a 3 still. Okay. Yeah. And we can place the 4 in box 4, column 3. Row 4.
Oh.
Because we have a locked hidden pair candidate with the 3 5s. I really got to work on my vocabulary. I'll study up.
Do you? I think this is more fun.
But I feel like if our goal is to educate the masses, we should know the terminology.
Yeah,
we're gonna have hordes of people out there not knowing the right wording for this.
Is the purpose of this to educate others on how to solve these Sudoku problems?
Well, what else is the purpose? Did we forget our mission statement?
Entertainment. Do we have a mission statement?
Apparently not.
We'll have to send it to my people. We'll go over it. When I signed a contract.
Oh, shoot. I just did that wrong. 4 + 8 is not 11. Said the math tutor. That was a shameless plug for my other business.
Math. Okay.
Great. Okay. So now, where are we at, people? Well, I bet we could do something with box 5. But maybe not. No, not really.
Feels too soon to.
It does feel too soon.
No. I bet we could do something with the column 8. Because we've got
the 2
can't really.
Never mind.
Oh, I was forgetting that in box 9 the segment is 4 digits long instead of 2 digits. Because I was gonna say we could like take the 3 different segments equaling 33 total and like add 7 and go, okay, we need 5 more to get to 45, but that's not how that works.
Word saddling.
Satelliting.
Word saddling.
Oh, okay. But I wonder if we've narrowed down what digits we could put in those 3.
I bet we have.
A segment of 3.
Mm-hmm.
Like there can't be a 9 in there.
Can't be a 9.
There can't be a 9 in there.
Can't be a 9.
So we know where the 9 is in column 8.
We do. Wait. Yes, up here. And we know where it is in box 6.
Wait, do we?
I think
Why can't it be?
Never mind. 9 + 2 is 11. Okay. What about this box? I feel like...
Hold on. We have 6 has to be on that path. I'm not done with column 8 yet, bro.
Okay. Well, I know. I was going to work on row 4, box 6, column 8.
So specific.
Still has a lot of digits, I guess.
I was just like, for those 3 digits, there has to be a 6 in there.
Yes, it does. There needs to be a 6.
Yeah.
Okay, we'll do that.
And 4? Yeah, there has to be a 4 in there too.
Yep.
Which means there has to be a 1.
But there could be a 1 in box 9.
Well, there is a 1 in box 9, but that segment has to add up to 11. And if there has to be a 4 and a 6, both on that segment, that's 10 total.
Okay.
So the missing digit.
The 6.
Oh.
Boom.
Cool. It also places the 1 in box 9.
1 in box 9, yes. Has to go right there. And the 2. Oh, things are falling into place. Feels so good.
This is more exciting than the FIFA World Cup, people.
It really is. People, you can watch highlights. Well, by the time this makes it onto YouTube, World Cup will be old history, so it's all good. This has to be a 4 because of the purple arrow.
What? Oh, right. Yeah.
6. Okay. Boop. And so 1, and we have our first column.
Oh, we should take a shot when we get a column done. Just kidding. Family friendly. A shot of water.
A shot of water. I've got some liquid IV in my water. Ooh, I'm not even getting paid by liquid IV, but I could be.
Liquid IV. DM us if you want
that called? Product placement.
Yeah. Oh, speaking of which, hey, Vyvanse. My insurance company keeps trying to make me pay cash for my ADHD medication. So if you want to collab, send me a sample.
What's Vyvanse?
We'll see how much it improves my Sudoku solving skills.
When my laser focus in. Which begs the question, are we matted up currently or not?
No. No. Nope. Because whenever I go, they're like, that'll be a scant $130, please. And I'll be like, it's supposed to be 95 cents.
Yeah.
No. Anyways, our medical system.
Let's move to Canada.
Oh, hey. Yeah, that box you have highlighted can't beat 7.
No 7. Great.
So we have our first parent box 529, baby.
Yes. That is most excellent.
Most.
What else? 29.
See what we could do. In box 6, that other segment could be 29. It could be. Is that what you're looking at too?
I was scanning to see what I was going to look at next, but we can look at that one.
I think it can only be 29.
29, 3, 8,
can't be
4,
can't
7.
Be 4, 7. Can't be 5, 6.
5, 6. Yeah. Okay. And then it can't be 2 right there. So great. 9 and 2. Fabulous. Ooh, and then this one seems pretty restricted. 7 or 8.
Can't see where you are.
Oh, you can't see.
Cursor has disappeared. Oh, there it is.
Just because it has to be bigger than the 6.
Yeah.
7, 8. And then that has to be a 9.
Oh, and the one next to the 4 has to be a 3. It's the only digit smaller than 4
that hasn't been played in box 6 already.
Yep.
The 8 has to go in this box because we've got a 4-8 locked.
Oh, there you go. Now we're cooking with gas.
And then we only have 2 more options. So 5, 7. 5, 7, 5, 7. But over here is a 5. There's a 3. Okay.
3, 4, 5. So
feel
6.
like maybe we could work.
Oh, we can put the 6 in box 4.
6 in box 4. 6 in box 4 right here. Got it. 6.
And then 8 and 9 are left. 8 has to go here. 9 there. Yep.
That's just basic Sudoku, people, in case you're having trouble following.
I was wondering.
But if you've made it this far, you probably have your basic Sudoku rules down, and we don't need to go over that.
Either that or you fell asleep and this is autoplay. You're like 7 hours into the autoplay algorithm. You started out watching.
We are sorry to interrupt this program, but it seems as if even our recording device has tired of us. We are definitely not inclined to re-record another solve, so we sincerely hope that you can solve the rest of run number 4 on your own. It's just basic Sudoku at this point. We believe in you.